So for number 17, it says a small regional carrier accepted 13 reservations for a flight with 11 seats. 9 reservations went to regular customers who will arrive for the flight, and each of the remaining passengers will arrive for the flight with a 40% chance independently of each other. So the first part of the question was to find the probability that overbooking occurs. So the first thing I did was I subtracted 9 from 11, and then I knew that 2 seats needed to be filled, and there were 13 reservations, so there were 4 potential passengers. And so I let X be the number of out of those 4 that would show up. And so I knew in order for overbooking to occur, X had to be greater than 2. So to find the probability of X is greater than 2, I used the binomial PDF function. And I did the probability of X equals 3 and the probability of X equals 4. And so I plugged those numbers in to the calculator function, and I got 0.1536 for the probability of X equals 3. And for the probability of X equals 4, I got 0.0256. So I added those together and got the probability of X is greater than 2, or the probability of overbooking, to be 0.1792. And then for the second half of the problem, I had to find the probability that the flight had empty seats. So to do that, I knew that in order for there to be empty seats, there had to be less than 2 of the 4 showing up. So I did the probability of X is less than 2, which is the same thing as the probability of X equals 0 plus the probability of X equals 1. So I found those using the binom PDF function. And I got 0.1296 for the probability of X equals 0 and 0.3456 for the probability of X equals 1. And I added those together and got the probability of the flight having empty seats, or the probability of X is less than 2, as 0.4752.